Hello everyone, how are you? On today's topic, we will be discussing how to solve problems involving permutations. But before we get started, allow me to show you our objectives. At the end of this lesson, you should be able to solve the number of permutations of n objects taken all at a time, solve the number of permutations of n objects taken r at a time, solve problems involving circular permutations, solve problems involving distinguishable permutations. Permutation refers to the different possible arrangements of a set of objects. The order of the arrangement is important. Thus, the arrangement of ABCD is not the same as the arrangement of BCDA. For this lesson, we're going to solve the different problems involving permutation of objects taken all at a time, permutation of n objects taken r at a time, circular permutation, and distinguishable permutation. Let's distinguish between permutation of objects taken all at a time and taken r at a time. Permutation of objects taken all at a time can be illustrated in the form of permutation of n, n. In this instance, all of the objects are included in the arrangement. Permutation of n, n can be computed in the form of n factorial, where n is the number of objects. Permutation of n objects taken r at a time can be illustrated in the form of permutation of n, r, where r is less than n. In this instance, not all objects are included in every arrangement. Permutation of n, r can be computed in the form of n factorial over quantity n minus r quantity factorial, where n is the number of objects and r is the number of objects taken at a time. Example number 1. In how many ways can 6 people line up at a single counter at a fast food restaurant? This is an example of permutation of objects taken all at a time. Therefore, we will employ the formula permutation of n, n is equal to n factorial. By substitution, we have p of 6, 6 is equal to 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. Hence, they have 720 ways to line up at a single counter at a fast food restaurant.
Let's look at another example. The game of Capture the Flag begins with 12 players. From the 12 players, how many ways can you choose to call captains? This is an example of permutation of n objects taken r at a time. Therefore, we will employ the formula permutation of n, r is equal to n factorial over quantity n minus r quantity factorial. In the given problem, 12 is the number of objects, so n is equal to 12, and we are taking 2 at a time, so r is equal to 2. By substitution, we have permutation of 12, 2 is equal to 12 factorial over 12 minus 2 quantity factorial. Simplify it. We have 12 factorial over 10 factorial. Expand both numerator and denominator and cancel 10 factorial both on the numerator and denominator. So for the final answer, we have 12 times 11 is equal to 132. Hence, we have 132 ways to choose 2 co-captains if there are 12 players.
For number 3, determine the number of possible ways to listen to 3 different songs from a list of 15. This is an example of permutation of n objects taken r at a time. Therefore, we will employ the formula permutation of n, r is equal to n factorial over quantity n minus r quantity factorial. In the given problem, 15 is the number of objects, so n is equal to 15, and we are taking 3 at a time, so r is equal to 3. By substitution, we have p of 15, 3 is equal to 15 factorial over quantity 15 minus 3 quantity factorial. Simplify it. We have 15 factorial over 12 factorial. Expand both numerator and denominator and cancel 12 factorial both on the numerator and denominator. So, for our final answer, we have 15 times 14 times 13 is equal to 2,730. Hence, there are 2,730 ways to listen to 3 different songs from a list of 15.
And lastly, for number 4, 4 people will be seated in a 9-seater vehicle. How many different ways can they be seated? This is an example of permutation of n objects taking r at a time. Therefore, we will employ the formula. Permutation of n, r is equal to n factorial over quantity n minus r quantity factorial. In the given problem, 9 is the number of objects, so n is equal to 9, and we are taking 4 at a time, so r is equal to 4. By substitution, we have p of 9, 4 is equal to 9 factorial over quantity 9 minus 4 quantity factorial. Simplify it. We have 9 factorial over 5 factorial. Expand both numerator and denominator and cancel 5 factorial both on the numerator and denominator. So for our final answer, we have 9 times 8 times 7 times 6 is equal to 3,024. Hence, they have 3,024 ways to be seated.
Apart from the linear permutations, which are the permutation of objects taken all at a time and permutation of objects taken r at a time, there are also circular permutations. Circular permutations are the permutations of objects when they are arranged in a circular pattern. An example of this is a sitting arrangement of people at a round table. The difference between a circular permutation and linear permutations is that in a circular permutation, there is no starting or ending point. This can be illustrated using permutation is equal to n factorial over n, or permutation is equal to quantity n minus 1 quantity factorial.
For number 1, how many ways can 8 friends be huddled in a circle? This is an example of circular permutation because the objects are arranged in a circle. Therefore, we will employ the formula permutation is equal to n factorial over n. In the given problem, 8 is the number of objects, so n is equal to 8. By substitution, we have 8 factorial over 8. Expand the numerator, which is 8 factorial, and cancel 8 both in the numerator and denominator. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 5,040. We can double check our answer by using the following simplified formula. Permutation is equal to quantity n minus 1 quantity factorial. By substitution, we have 8 minus 1 quantity factorial. 8 minus 1 is 7, so we have 7 factorial, and that is 7 times 6 times 5 times 4 times 3 times 2 times 1, that is 5,040 once again. Hence, they have 5,040 ways to be huddled in a circle.
And lastly, for number 2, how many different ways can you put 11 distinct charms on a circular bracelet? This is an example of a circular permutation because the objects are arranged in a circle. Therefore, we will employ the formula. Permutation is equal to n factorial over n. In the given problem, 11 is the number of objects, so n is equal to 11. By substitution, we have 11 factorial over 11. Expand the numerator, which is 11 factorial, and cancel 11 both in the numerator and denominator. So we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 3,628,800. We can double check our answer by using the following simplified formula. permutation is equal to quantity n minus 1 quantity factorial. 11 minus 1 is 10, so we have 10 factorial, and that is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 3,628,800 once again. Hence, we have 3,628,800 ways to put 11 distinct charms on a circular bracelet.
The last type of permutation that we're going to talk about is distinguishable permutations. Distinguishable permutations refer to the permutations of a set of objects where some of them are alike. The number of distinguishable permutations of n objects when p are alike, q are alike, r are alike, and so on is given by p is equal to n factorial over p factorial times q factorial times r factorial, and so on.
Example number 1. Determine the number of distinguishable permutations of letters from the word Tennessee. This is an example of distinguishable permutation because some of the objects are similar. In the word Tennessee, the letter E comes 4 times, the letter N comes twice, and the letter S comes twice as well. We can now employ the formula for distinguishable permutations. Permutation is equal to n factorial over p factorial times q factorial times r factorial, and so on. By counting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, we can say that there are 9 objects. Thus, 9 factorial will be written in the numerator. Since we have 4 letter E in the word Tennessee, we will write 4 factorial in the denominator. We have 2 letter N, so we will write 2 factorial in the denominator. Lastly, we have 2 letter S, so another 2 factorial in the denominator. After substitution, the next step is to evaluate. 9 factorial is equal to 362,880. Simplify, the denominator 24 times 2 is equal to 96. And the last step, 362,880 divided by 96 is equal to 3,780.
Let's look at another example. How many distinguishable permutations of letters are there in the word accommodation? This is an example of distinguishable permutation because some of the objects are similar. In the word accommodation, the letter O comes 3 times, the letter A comes twice, the letter C comes twice, and the letter M comes twice as well. We can now employ the formula for distinguishable permutations. Permutation is equal to n factorial over p factorial times q factorial times r factorial, and so on. By counting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Therefore, we can say that there are 13 objects. Thus, 13 factorial will be written in the numerator. Since we have 3 letter O's in the word accommodation, we will write 3 factorial in the denominator. We have 2 letter A, so we will write 2 factorial in the denominator. We also have 2 letter C, so we will write 2 factorial in the denominator. Lastly, we have 2 letter M, so another 2 factorial in the denominator. After substitution, the next step is to evaluate. 13 factorial is equal to 6,227,020,800. Additionally, 3 factorial is equal to 6, and 2 factorial is equal to 2. So we have 6 times 2 times 2 times 2 on the denominator. Simplify the denominator 6 times 2 times 2 times 2 is equal to 48. And the last step, 6,227,020,800 divided by 48 is equal to 129,729,600.
Ang susunod na programa ay rated G. Ito ay pwede sa lahat ng manonood.
Hello Philippines, hello world. I am your host, Jaime Manalang of Matinee. For today's episode, we will having a quiz with competition and it's all about solving problems involving combinations. Our contestants for this episode are Genesis John and Keith Lilo, and Cindy Zaira and Francis Leia. So, before we start our competition, we will watch this video lesson that Group Mapagmahal of 10 Diamond prepared for us that you can answer the questions effortlessly.
Greetings everyone!
Are you feeling well today? Do you know what we are going to talk about?
Aren't you curious what is it? And do you have any thoughts about what is combinations or how to solve one of them? If you don't have any idea, then it's your lucky day because in this video, you are about to learn to solve problems involving combinations. Before we start, I would like to introduce our group.
We are the group 2. For our learning objectives, at the end of this video, you must be able to first, distinguish how to get possible combinations of objects. Second, demonstrate combinations of objects in real-life cases. Third, determine and illustrate the formula for combinations of n objects taken are at a time. Lastly, learn to solve problems about combinations of objects.
Let's start by defining combination. Combination is mostly defined as an arrangement of objects where the order in which the objects are selected does not matter. Combination means selection of things, where the order of things has no importance. For us to understand combination, here's one of the example. 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, 1 are just the same. Therefore, it is just one combination.
Now, for you to understand combinations, let's have this problem. Syra's birthday party is next week. She needs to invite only 2 of her friends, namely Kit, Frances, Genesis, and Cindy. In how many ways can Syra choose 2 out of 4 of her friends? Now, let us try to list all the possible arrangements that Syra can do. First, she can choose Kit and then Frances, or Frances then Kit. This is just one combination because remember that the order is not important. Next, she can choose Kit and then Genesis, or Genesis then Kit. For our third combination is Kit and then Cindy, or Cindy then Kit. Fourth combination is Frances and then Genesis, or Genesis then Frances. Fifth combination is Frances then Cindy, or Cindy then Frances. And for our last combination, she can choose Genesis and then Cindy, or Cindy then Genesis. After listing all the possible combinations, therefore, we have 6 ways can Syra select 2 friends out of the 4 mentioned names.
As we notice, what we did there is time consuming. That's why we have a formula that we can use to solve combinations most efficiently. The formula for combinations without repetition can be demonstrated in the form of combination of n, r is equal to n factorial
over quantity n minus r quantity factorial times r factorial, in which n is the total number of objects and r is the number of objects taken at a time. Earlier, we tried to solve a problem. Now, let's try this formula to check if our answer is correct. In how many ways can Syra choose 2 out of 4 of her friends? First, we must determine Rn and R in the given problem. Since the total of Syra's friends is 4, 4 will be Rn, and we're going to choose 2 out of her friends. Thus, R is equal to 2. Given the formula, combination of n, r is equal to n factorial over quantity n minus r factorial multiplied by r factorial.
After that, we can now substitute the given values. So we have combination of 4, 2 is equal to 4 factorial over quantity 4 minus 2 factorial times 2 factorial. By simplifying the equation, 4 minus 2 is equal to 2. We can write our numerator 4 factorial in the form of 4 times 3 times 2 factorial so that we can cancel 2 factorial on both numerator and denominator. By getting the product of the factors of the numerator and denominator, we have 4 times 3 is equal to 12. Also, we know that 2 factorial is also equal to 2. And lastly, for our final step, 12 divided by 2 is equal to 6. This means that Syra has 6 ways to pick 2 of her friends out of her 4 friends.
To understand more, let's have another example. Assume that you need 5 pets at home. You visited an animal shelter and they have 5 dogs, 4 cats, and 3 rabbits. In how many ways can you select 5 assorted pets out of the 12 different animals? We can solve this problem using the combinations. But first, we must identify our n and our r in the given problem. Since the total number of animals is 12, 12 will be our n, and we're going to choose 5 animals, thus r is equal to 5. Given the formula, combination of n, r is equal to n factorial over quantity n minus r factorial multiplied by r factorial. After that, we can now substitute the given values. So, we have combinations of 12, 5 is equal to 12 factorial over quantity 12 minus 5 factorial times 5 factorial. By simplifying the equation, 12 minus 5 is equal to 7. We can write our numerator 12 factorial in the form of 12 times 11 times 10 times 9 times 8 times 7 factorial so that we can cancel 7 factorial on both numerator and denominator. We know that 5 factorial is equal to 5 times 4 times 3 times 2 times 1. By getting the product of the factors of the numerator and the denominator, we have 12 times 11 times 10 times 9 times 8 is equal to 95,040. Also, 5 times 4 times 3 times 2 times 1 is equal to 120. And lastly, for our final step, 95,040 divided by 120 is equal to 792. This means that you have 792 ways you can pick 4 pets out of the 12 animals that the shelter has.
And for our last example, there are 20 choirs in a church, 12 sopranos and 8 altos. In how many ways can a conductor of 4 sopranos and 2 altos be formed? So, 4 sopranos can be selected in a combination of 12, 4 ways. Since we have 12 sopranos and we're going to select 4. The next two altos can be selected in a combination of 8,2 ways. Since we have 8 altos and we're going to pick 2 altos. Using the fundamental counting principles, we can find the number of ways that the conductor be formed by using the combination of 12, 4 multiplied by the combination of 8, 2. Let's start solving the combinations of 12, 4. In our given, 12 is our n, while the 4 is our r. Using the combinations formula, combination of n, r is equal to n factorial over quantity n minus r quantity factorial multiplied by r factorial. We can now substitute the given values. So, we have a combination of 12, 4 is equal to 12 factorial over quantity 12 minus 4 quantity factorial times 4 factorial. Now, we have to start computing inside of the parentheses. We have 8 factorial coming from the 12 minus 4 quantity factorial. Following, our next step is to rewrite the numerator in the form of 12 times 11 times 10 times 9 times 8 factorial. To cancel 8 factorial on the numerator and denominator, multiply the remaining factors. 12 times 11 times 10 times 9 is equal to 11,880, and 4 times 3 times 2 times 1, which is equal to 24. We can now move on our last step. 11,880 divided by 24 is equal to 495. Now, let us solve the combination of 8, 2. In our given, 8 is our n and 2 is our r. Again, by using the formula of combinations, let us substitute the given values. So, we have the combination of 8, 2 is equal to 8 factorial over quantity 8 minus 2 quantity factorial. After substitution, let us evaluate the parentheses. 8 minus 2 is equal to 6. So, we have 8 factorial over 6 factorial times 2 factorial. 8 factorial can be written in the form of 8 times 7 times 6 factorial, so that we can cancel 6 factorial on the numerator and our denominator. 56 divided by 2 is equal to 28. So in this combination, we have 28 ways of alto can be formed.
Since we already have the values of the combinations of 12, 4 and the combinations of 8, 2, we can now substitute the given values. So, the combination 12, 4 is equal to 495 multiplied by the combination of 8, 2, which is equal to 28. 495 times 28 is equal to 13,860 ways. Thus, we have 13,860 ways can the conductor of 4 sopranos and 3 altos can be formed.
If we have a combinations without repetition, then we also have combinations with repetition. To understand more, let's have an example. There are 4 different fruits on the table. Your mother told you that you can only eat 2 fruits. In how many combinations can you choose among the 4 different fruits? If you can choose 2 fruits at a time, then you can have 2 fruits times 2. In this case, you can select banana and banana, banana and orange, banana and apple, banana and grapes, apple and apple, apple and orange, apple and grapes, orange and orange, orange and grapes, and grapes and grapes. After listing all the possible combinations, Therefore, we have 10 ways to choose 2 fruits out of the 4 fruits. Remember that order does not matter. That's why the fruits can be repeated. There is also a formula for combinations with repetition. The formula of combinations when repetition is allowed is combination of n, r is equal to quantity n plus r minus 1 quantity factorial over r factorial quantity n minus 1 quantity factorial, in which n is the total number of objects and r is the number of objects taken at a time. To make it clear, let's try to use the formula in our previous example to check if our answer is correct.
There are 4 different fruits on the table. Your mother told you that you can only eat 2 fruits. How many combinations can you choose among the 4 different fruits? The formula of combination when repetition is allowed. Combination of n, r is equal to quantity n plus r minus 1 quantity factorial over r factorial quantity n minus 1 quantity factorial, in which n is the total number of objectives and r is the total number of objectives taken at a time. We can now substitute the given values. So, we have a combination of 4, 2 is equal to the quantity 4 plus 2 minus 1 quantity factorial over 2 factorial quantity 4 minus 1 quantity factorial. We can now start computing inside the parentheses. We have 5 factorials over 2 factorials multiplied by 3 factorials. Following our next step, we write the numerator in the form of 5 times 4 times 3 factorial to cancel 3 factorials on the numerator and denominator. In addition, multiply the remaining factors. 5 times 4 is equal to 20, and 2 times 1 is equal to 2. We can now move on our last step. 20 divided by 2 is equal to 10. Therefore, you have 10 ways to choose 2 fruits.
Remember that combination of objects taken all at a time is always equal to 1. For example, 8, 8, 25, 25, 17, 17, 12, 12, all of this is equal to 1. In addition, for this example, 8, 1 is equal to 8. 50, 1 is equal to 50. 5, 1 is equal to 5. 10, 1 is equal to 10. It is always equal to the number of objects, or the n.
Thank you for that wonderful video 10, Diamond. Now, let's start our competition. I hope that you are all ready and good luck. For question number 1, it is an arrangement of objects for the order, yes? Combination. Correct. Number 2. A father goes to the grocery store after his work. He passed by the ice cream section and he thinks of buying his 3 children, him and his wife a cup of it each, but there are 9 available flavors of his choice. In how many ways can he choose 5 different of ice cream flavors for his children? Yes?
126.
Correct. It's all even. Okay, for question number 3. There are 7 colored acrylic paint to be used in the art contest. All paints are in different colors. In how many ways can you choose 3 acrylic paint to use? Indeed, 35 ways. Correct, 2 points. For our question number 4, what is the formula of combination without repetition? Genesis?
N factorial over quantity n minus r factorial multiplied by r factorial.
Correct. And for our last number, In how many ways you can choose 8 workers out of 20 workers? Frances?
125,970.
Correct? Good luck, everyone. Congrats to all of you. You did well. So, for our winner for our Quiz Bee competition is Frances Leia and Cindy Gato. Congrats to all of you. And that's how our competition ends. We hope that you enjoyed it. Again, this is your host Simon Manalang of Matini, now signing off. Thank you.
Good day, students and Kamathusais. I hope you're having a wonderful day.
For today's video, we have a wonderful lesson that will be tackled today.
Sit back and learn as we discuss all about the difference between permutation and combination.
At the end of this video, you should be able to differentiate permutation from combination and vice versa.
You are also expected to know the keywords to identify one and the other, as well as learn how to identify permutation and combination questions.
But no pressure. Feel free to take notes throughout the lesson.
Before we start, we would like to introduce ourselves as we learn about this lesson together. Hi, I'm Mark Luis Apello.
Hello, I am Venetia Garcia.
Hi there, I'm Sabrina Noela Manulit.
Greetings! I am Dianzas Angel Pasion.
Hey, I am Chris Daniel Kitalig. Now you know you have some company as you listen to our lesson.
Now, how about we start with our discussion?
We'll start with what is a permutation. A permutation is an arrangement of objects in a definite order. It is a way, especially one of several possible variations, in which a set or number of things can be ordered or arranged. Remember, in permutation, order is important.
Let's do an example of permutation question. How many ways can Coach Arataki Ito arrange the seats of first, second, and third places in a row? This is considered a permutation question because of the order of the winners matter, with the keyword arrange. In this problem, n is equal to 3 because we'll be arranging first, second, and third places. And each place is occupied by only one winner, so r is equal to 1. We have the formula permutation of n, r is equal to n factorial over quantity n minus r quantity factorial.
Now we substitute the value of n and r to the formula, which gives us permutation of 3, 1 is equal to 3 factorial over 3 minus 1 quantity factorial. Then simplify, we have 3 factorial over 2 factorial since 3 minus 1 is equal to 2. Expand the numerator and denominator, we have 3 times 2 times 1 over 2 times 1 and cancel 2 and 1 on the numerator and denominator. And now we are left with 3.
A combination is a mathematical technique that determines the number of possible arrangements in a collection of terms, where the order of the selection does not matter.
Let us proceed to an example of combination. Professor Kim Ming-yu choosing 3 representatives for MTOP competition out of 30 students. This is considered a combination question because the order of the representatives doesn't matter, with the keyword choosing. In this problem, n is equal to 30 because we'll be choosing 3 representatives that represent our r is equal to 3.
we have the formula combination of n, r is equal to n factorial over quantity n minus r quantity factorial times r factorial.
Then simplify. We have 30 factorial over 27 factorial, since 30 minus 3 is equal to 27 and times 3 factorial. Expand the numerator and the denominator. We have 30 times 29 times 28 times 27 and so on, over 27 times so on. And cancel all numbers of 27 below among the numerator and also 27 below on the denominator. Let us multiply the remaining factors. Let us proceed first in the numerator. 30 times 29 times 28 is equal to 24,360. And on the denominator, we have 3 times 2 times 1 is equal to 6. Last step, 24,360 divided by 6 is equal to 4,060.
Now let us proceed on a Venn diagram that states the similarity and differences of permutation and combination.
Permutation and combination are both mathematical concepts. Permutation is all about arrangement and order matters. However, combination is all about selection and order does not matter.
Combinations and permutations with the same n and r values are less than permutations, and I want you to remember that a permutation is an ordered combination.
Visualizing each problem first will assist you in determining if the problem is about combination or permutation. In addition, we have the following keywords to help you identify a combination question.
Keep an eye out for the following keywords in a question to identify a permutation question: arrangements, ordered ways, unique, and permutation. If you see one of these terms in a question, it means it's a permutation question. More specifically, some of the keywords for combination include select, choose, pick, and combination. Look for these phrases whenever you read the questions, since they are important indications that clearly tell us that the question is a combination. Furthermore, keep in mind that keywords may or may not be present in the questions.
In scenario like that, what can we do? Let us find out in this example. There are 8 teams in a certain league, and each team plays with the other team exactly 1. What is the total number of games played in the league? First, examine the problem carefully. Visualize the scenario presented in the question and then think in terms of combination and arrangement. By doing that, we are given:
there are 8 teams in a certain league, and each team plays with the other teams exactly once. What is the total number of games played in the league? There are 8 teams in a league. We know that each game is played between 2 teams. The match between Team A and Team B is the same as the match between Team B and Team A. Thus, for each match to happen, we must select 2 teams only, and in this case, the arrangement will not matter. You can observe we arrive at the keyword select by dissecting the given information carefully and making meaningful inferences. Now, we only have to find the number of ways of selecting 2 teams from 8 teams. Hence, total number of games played is equal to 8C2 is equal to 28 matches.
Welcome to the Word Bank, where we will look at important terms that was used in the lesson. First, we have arrangement. These refer to the different possible arrangements of a set of objects. Our second word of the day is selection. These refer to the number of ways of selecting from a set when the order is not important. Lastly, we have order, that determine the arrangement of things in relation to each other according to a particular sequence or pattern.
Raise your hand if you are excited about our mini quiz titled Check Your Understanding. In this part, we will test your knowledge and learning about our discussion. You just simply need to identify which is a permutation question and a combination question. Are you ready? Let's go.
Letter A. How many permutations of 4 different letters are there? Chosen from the 26 letters of the alphabet.
Letter B. Picking a leader and 2 assistant leaders from a group of 10.
Letter C. Arrangement of 10 pebbles around a vase.
Letter D. Making 5 bags for Lenny's birthday out of 10 in Louis Vuitton.
Letter E. Selection of a committee of 5 from 20 people.
That ends our discussion. Hope you learned new knowledge and skills about math. We believe that, like us, you truly enjoyed our video discussion.
It has been a wonderful time serving you all, our Kamat Husay. Tune in with us next time for more fun learning.
Good morning, class. For today's lesson, we will tackle the probability of union of 2 events. Before we proceed on our discussion, may we present to you our objectives. After this lesson, you should be able to illustrate probability of union of 2 events, solve the probability of A union B, differentiate mutually and non-mutually exclusive events, and solve problems involving mutually and non-mutually exclusive events. But before we start, let us first know what is probability. Probability, the extent to which an event is likely to occur, measured by the ratio of the favorable cases to the whole number of cases possible. Now, let's get started. Given, for example, we have to randomly choose a card in a standard deck of cards. Notice that each cards are completely different from each other. In a deck of 52 cards, we can choose either a club, diamond, spade, or heart. Using probability of simple event, the probability of getting a spade in a deck of cards is given by 13 all over 52. Since you have 13 clubs, so the numerator is 13 and the denominator is 52. Since we have 52 possible outcomes in the deck of cards. Or if you simplify it, it will be 1/4. Since if we divide 13 by 13 is equal to 1 and 52 divided by 13 is 4. Notice that each symbol is equally distributed in a deck of cards. The number of possible outcomes in a deck of cards, which is 13, is the same as the number of possible outcomes of the diamond, spade, and even heart. So, the probability of getting a diamond is also equal to 1/4. The probability of getting a spade is also 1/4. And the probability of getting a heart is equal to 1/4. If you add all the possibilities of each symbols, you will get 4 all over 4. Since 1 plus 1 plus 1 plus 1 is equal to 4, then copy the same denominator, which is 4. And 4 is equal to 1. In probability, 1 means certain. It means the event will surely happen. Therefore, randomly choosing a card in the standard deck of cards, the probability of getting a club or diamond or spade or heart is equal to 100%. Again, if we use the conjunction or in probability, that means addition, and we are referring the union of 2 or more events. Just like in this example, we can say that the probability of getting a club union to the probability of getting a diamond union the probability of getting a spade union probability of getting a heart is equal to 100%. What about if we want to find the probability of union of two events? The probability of union of two events is classified into two: mutually exclusive events or non-mutually exclusive events. Two events is said to be mutually exclusive if events have no outcome in common, or if two events cannot happen at the same time. It is also referred as disjoint events and can be illustrated using two circles without overlapping, since event A is totally different from event B. In mutually exclusive events, the probability that either A or B occurs is equal to the probability of A plus the probability of B. Let's have an example. What is the probability of drawing a queen or a king in an ordinary deck of cards? The two events are event A, getting a queen card, and event B, getting a king card. The possible outcomes of event A are a queen of clubs, a queen of hearts, a queen of diamonds, a queen of spades, and the possible outcomes of the event B are the king of clubs, king of hearts, king of diamonds, and king of spades. The probability of getting either a king or queen card, we are going to find the probability of getting a queen card first, and that is 4 all over 52. Since we have 4 possible outcomes and 52 numbers of total cards in the deck of cards. And then we are going to find the probability of getting a king card, and that is also 4 all over 52. Since we have 4 possible outcomes and 52 number of total cards in the deck of cards. To solve the probability of getting a queen or king card, we will add the probability of getting a queen card and the probability of getting a king card. 4 plus 4 is equal to 8 and copy the denominator, which is 52. We can simplify it by dividing the numerator and denominator in 4. 8 divided by 4 is equal to 2 and 52 divided by 4 is 13. Therefore, the probability of getting a king or queen card is 2 all over 13.
A bag contains 9 white balls, 15 orange balls, and 11 red balls. If a ball is drawn, find the probability that it is a white or a orange ball. The two events are event A is getting a white ball and event B is getting an orange ball. The possible outcomes of event A are 9 white balls, and the possible outcomes of event B are 15 orange balls. To get the probability of getting either a white or orange ball, we are going to find the probability of getting a white ball first, and that is 9 over 35. Since we have 9 possible outcomes and 35 number of total balls in the bag, and then we are going to find the probability of getting an orange ball, and that is 15 over 35. Possible outcomes and 35 total number of balls in the bag. To solve the probability of getting a white or orange ball, we will add the probability of getting a white ball and the probability of getting orange ball. 9 plus 16 is equals to 24, and copy the denominator 35. Therefore, the probability of getting a white or orange ball is 24 over 35.
Example 3. A card is drawn at random from a deck of cards. Find the probability of getting a heart or spade. The two events are event A is getting a heart and event B is getting a spade. The possible outcomes of event A are 13 heart cards and the possible outcome of event B are 13 spade cards. To get the probability of getting either a heart or spade, we are going to find the probability of getting a heart card first, and that is 13 over 52. Since we have 30 possible outcomes and 52 numbers of total numbers of cards in a deck of cards. And then we are going to find the probability of getting a spade, and that is also 13 over 52. Since we have 13 possible outcomes and 52 numbers of total numbers of cards in a deck of cards, to solve the probability of getting a heart or spade card, we will add the probability of getting a heart and the probability of getting a spade. 13 plus 13 is equal to 26, and copy the denominator 52. We can simplify by dividing the numerator and denominator by 26. Therefore, the probability of getting a heart or spade card is 1/2.
After we discuss mutually exclusive events, let us talk about non-mutually exclusive events. Non-mutually exclusive events is completely different from mutually exclusive events because the union of events have outcomes in common, or the two events can happen at the same time. This is also referred as the joint events and can be illustrated using two overlapping circles, where the overlapping region is the intersection of the two events. In non-mutually exclusive events, the probability that A or B occurs is equal to the probability of A plus probability of B minus the probability of A and B. The probability of A and B is the intersection of two events.
If a card is drawn from an ordinary deck of cards, find the probability of getting a spade or a face card. The two events are event A is getting a spade card and event B is getting a face card. There are 13 possible outcomes for event A, and there are 12 possible outcomes for event B. Notice that both events have possible outcomes in common, which are Jack, Queen, and King of Spades. To find the probability of getting spade or face card, we are going to find the probability of getting a spade first, and that is 13 over 52. Since there are 13 possible outcomes and 52 total cards in a deck of cards, and the probability of getting a face card, and that is 12 over 52. And then get the probability of getting a spade and face card, and that is 3 over 52. Since we have three similar outcomes, which are Jack, Queen, and King of Spade. Hence, the probability of getting a spade or face card is equal to the probability of getting a spade plus the probability of getting a face card minus the probability of getting a spade and face card. 13 over 52 plus 12 over 52 minus 3 over 52 is equals to 22 over 52. We can simplify it by dividing the numerator and denominator by 2, and that is equals to 11 over 26.
Example number 2. What is the probability that a number selected at random from the first 30 positive integers is exactly divisible by 3 or 4? The two events are event A, selecting a positive integer divisible by 3, and event B is selecting a positive integer divisible by 4. There are 9 possible outcomes in event A, and those are 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And 7 possible outcomes in event B, and those are 4, 8, 12, 16, 20, 24, and 28. To find the probability of selecting a positive integer divisible by 3 or divisible by 4, we are going to find the probability of selecting a positive integer divisible by 3 first, and that is 10 over 30, since there are 10 possible outcomes and first 30 positive integers. Then find the probability of selecting a positive integer divisible by 4, and that is 7 over 30. Then, the probability of selecting a positive integer divisible by 3 and divisible by 4, which is 2 over 30, since there are two outcomes in common in event A and event B, and those are 12 and 24. The probability of selecting a positive integer divisible by 3 or divisible by 4 is equals to 10 over 30 plus 7 over 30 minus 2 over 30, and that is equals to 15 over 30, or 1/2, since we can simplify it by dividing 15 in numerator and denominator.
Example 3. In a deck of cards, what is the probability of getting a red card or an ace? The two events are event A, getting a red card, and event B, getting an ace. There are 26 possible outcomes in event A and 4 outcomes in B. To find the probability of getting a red card or an ace, find the probability of getting a red card first, and that is 26 over 52. And the probability of getting an ace, and that is 4 over 52. Then the probability of getting a red card and an ace, and that is 2 over 52. Since there are two aces in red cards, and those are ace of hearts and ace of diamonds. To find the probability of getting a red card or an ace, add the probability of getting a red card, which is 26 over 52, and the probability of getting an ace, and that is 4 over 52, minus the probability of getting a red card and an ace, and that is 2 over 52. 26 over 52 plus 4 over 52 minus 2 over 52 is equals to 28 over 52, or 7 over 13 if you simplify it by dividing 4 in both numerator and denominator.
Again, in a deck of cards, getting a 4 or getting a face card are mutually exclusive events, because you cannot get a 4 at the same time a face card in a deck of cards if you are going to select a random card. However, getting a diamond or getting a face card are non-mutually exclusive events, because you can select a diamond at the same time a face card if you're going to select a random card, and those are the Jack of Diamonds, the Queen of Diamonds, and the King of Diamonds.
Good day, everyone! Our topic for today is about solving problems involving probability of independent events. But before we start, let me just give you a reminder. Your future depends on what you do today, and your today has already started.
At the end of this video,
You are expected to illustrate probability of independent events.
Differentiate between independent events and dependent events.
And lastly, solve problems involving probability of independent events.
What does probability means? Probability refers to the chance or possibility that an event will occur. It is the ratio of the number of desired outcomes to the total number of outcomes. The formula of getting probability is probability equals the number of desired outcomes over total number of outcomes.
Independent event refers to the occurrence of one event not affecting the probability of another event.
The formula on solving problems involving probability of independent events is probability of A and B is equals to probability of A multiplied by probability of B.
We will use the conjunction and to indicate that the operation is multiplication.
Next is dependent events. It is referred to the occurrence of one event affecting the probability of another event.
The formula for solving problems involving probability of dependent event is probability of A and B is equals to probability of A multiplied by probability of B following A. The first problem is 10 yellow-green marbles, 3 blue marbles, and 7 red marbles are contained in a jar. Ella picks up a marble and tosses it back into the jar. She draws a second marble. What is the probability that the first marble is blue and the second one is red? The keyword on this problem is tosses it back into the jar, because probability of independent events is a probability with replacement. To solve this, we will use the formula of independent events, which is probability of A and B is equals to probability of A multiplied by probability of B. Substitute the given. Probability of A refers to the probability of getting a blue marble amongst all marbles. So it will become 3 over 23 since there are 3 blue marbles and 23 total number of marbles. Multiplied by 7 over 23 since there are 7 red marbles on the entire marbles. Now we will multiply the given 3 over 23 multiplied by 7 over 23. We need to multiply the numerators first. 3 times 7 is 21. Then let's multiply the denominator. 23 times 23 is 529. Therefore, the probability of getting the first marble blue and the second one is red is 21 over 529.
Problem number 2. What is the probability of getting a diamond and clubs card with replacement from a standard deck of cards? The keyword used on this problem is with replacement. A standard deck of cards contains 52 cards. And in that 52 cards, there are 4 types of cards, which are spade, clubs, heart, and diamond. The probability of A and B is equal to the probability of A multiplied by the probability of B. The probability of A refers to the probability of getting diamond card, and the probability of B refers to the probability of getting clubs card. The probability of getting diamond card is 13 over 52. 13 is equal to the total number of diamond cards in a standard deck of cards, and 52 is the total number of cards in a standard deck of cards. The probability of getting clubs card is also 13 over 52. 13 is equal to the number of clubs card in a standard deck of cards, and 52 is the total number of cards. Simplify the given by dividing both numerator and denominator by 13, and we will get 1/4. Then, we will just need to multiply this given. 1 times 1 is 1, and 4 times 4 is 16. which is a total of 1 over 16. Therefore, the probability of getting a diamond and clubs card in a standard deck of cards is 1 over 16.
Problem number 3. You have 3 5 peso coin and 5 1 peso coin. You take out one coin and then put it back. Then, you take out another coin. What is the probability that you take out a 1 peso coin and then a 5 peso coin? The keyword on this problem is put it back. We will solve this using the formula probability of A and B is equal to probability of A multiplied by probability of B. Substitute the given 5 1 peso coin over 8 coins multiplied 3 5 peso coin over 8 coins. 5 times 3 is 15. 8 times 8 is 64. The final answer is 15 over 64. Therefore, the probability of getting 5 peso coin and then 1 peso coin is 15 over 64.
Problem 4. Suppose you spin each of the two spinners. What is the probability of spinning an even number and a vowel? The first wheel contains number 1, 2, 3, 4, 5, and 6, and the second wheel have 5 letters S, T, R, O, and P. The probability of getting an even number on the first wheel is 3 over 6, or 1/2. Since there are 3 even numbers on the wheel of 6 numbers, next is the probability of getting a vowel letter in the second wheel is 1 over 5, because that is the only vowel in the wheel, which is the letter O. To solve this, we will just multiply the given 1 times 1 is 1, and 2 times 5 is 10. The final answer is 1 over 10. Therefore, the probability of getting an even number and a vowel is 1 over 10.
Problem 5. A juggler has 7 red, 5 green, 4 blue balls. During his stunts, he accidentally dropped a ball, then picked it up. As he continued, another ball falls. What is the probability that first ball that was dropped is blue and the second ball is green? To solve this, we will use the formula of independent events, which is the probability of A and B is equal to the probability of A multiplied by probability of B. Substitute the given 4 over 16, 4 refer to the blue balls and 16 refer to the total of number of balls. Multiply by 5 over 16, 5 refer to the green balls. Now, let's solve the equation. 4 multiplied by 5 is 20. 16 times 16 is 256. So the answer is 20 over 256. We can divide both numerator and denominator by 4 to get the simplified answer, which is 5 over 64. Therefore, the probability that the first ball that was dropped is blue and the second one is green is 5 over 64.
Last problem. If you will roll a 6-sided die and flip a coin, what is the probability of rolling a 3 and getting tail? By analyzing this problem, we will know that this is an independent event because rolling a die does not affect flipping a coin, or both events does not affect each other. To solve this, we will use the formula probability of A and B is equal to probability of A multiplied by probability of B. The probability of getting a 3 in a 6-sided die is 1 over 6, and the probability of getting a tail in a coin is 1/2. We will multiply it. 1 times 1 is equal to 1, and 6 times 2 is equal to 12. Therefore, the probability of rolling a 3 and getting a tail is 1 over 12.
everyone. Today we are gonna be talking about Lesson 6. Solving problems involving probability of dependent events. But before that, let us introduce ourselves first.
Hi, I'm Lolly.
Hi, I'm Elton.
Hi, I'm Althea.
Hi, I'm Marian.
Hello everyone, I'm Carl.
And we are the reporters. Here is the quote of the day. Don't let what you cannot do interfere with what you can do. By John Wooden. Now what is probability of dependent events? It is when the outcome of one event affects the outcome of a second event. In other words, two events are dependent if the occurrence of one event influences the probability of another event. If two events, A and B, are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A occurs. In short, the probability of A and B is equal to the probability of A times the probability of B following A. Probability of dependent events is also known as probability without replacements. Now here are the examples.
Example number 1. A purse contains of 4 $5 bills, 5 $10 bills, and 3 $20 bills. Two bills are selected without the first selection being replaced. Find the probability of $5, then $5. We know that this problem is a probability of dependent event because it has the statement without the first selection being replaced. Since we know that the probability of dependent event is known as probability without replacement, we are going to use the formula of probability of dependent events to solve this problem, which is probability of A and B is equal to probability of A times probability of B following A. First, we are going to get the probability of $5, which is 4 over 12. The number 4 was derived from the number of $5 bills, while the 12 was derived from the total number of all bills. Next is probability of $5 after $5, which equates to 3 over 11. Both of these numbers were derived from the probability of $5, but one is subtracted because the first $5 bill was already taken. After that, the probability of $5, then $5. We are going to substitute to the original formula, so now we have probability of $5 times probability of $5 after $5. Lastly, we are going to substitute again. So we have 4 over 12 as the probability of $5 times 3 over 11 as the probability of $5 after $5. The only thing you need to do is to multiply. 4 times 3 is equal to 12, then 12 times 11 is equal to 122. As we can see, we can simplify this number using their GCF, or greatest common factor, which is 12. So if simplified, the answer will be 1 over 11. And then the probability of drawing a $5 bill and then a $5 bill is 1 over 11.
Example number 2. A bag contains of 6 red, 5 blue, and 4 yellow marbles. 2 marbles are drawn, but the first marble drawn is not replaced. We know that this is a problem of probability of dependent events because it is stated that there is no replacement. Now we have A, find the probability of red, then blue. And B, find the probability of blue, then blue. We are going to use the formula for probability of dependent events to solve both of these problems. A. Probability of getting red is equal to 6 over 15 because there are 6 red marbles and total of 15 marbles. Then, probability of getting blue after red, which is equal to 5 over 14. Both numbers were derived from the probability of red, but one is subtracted because the first marble is already taken. Lastly, the probability of red, then blue, which is equal to 6 over 14 times 5 over 14, which is equal to 30 over 210 or 1 over 7 if simplified. Next is B. The probability of getting blue is equal to 5 over 15 because there are 5 blue marbles and a total of 15 marbles. Then the probability of getting blue after blue is 4 over 14. Again, both of these numbers were derived from the probability of getting blue, but one is subtracted because the first marble is already taken. Lastly, the probability of blue, then blue, which is equal to 5 over 15 times 4 over 14, which is equal to 20 over 210 or 2 over 21 if simplified. The probability of drawing a blue marble and then a blue marble is 2 over 21. So we have A, the probability of red, then blue is equal to 1 over 7, and B, the probability of blue, then blue is equal to 2 over 21.
Example number 3. There are 6 black pens and 8 blue pens in a jar. If you take a pen without looking and then take another pen without replacing the first, what is the probability that you will get 2 black pens? We instantly know that this problem is a probability of dependent events because of the part without replacing the first. So we are going to use the formula of probability of dependent events. First, the probability of getting first black pen, which is equal to 6 over 14, or if simplified, 3 over 7. Next is the probability of getting second black pen, which is equal to 5 over 13. Both of these numbers were derived from the probability of getting first black pen, but one is subtracted because the first black pen is already taken. Then after that, the probability of black, which is equal to 3 over 7 times 5 over 13. Multiply 3 to 5 and you will get 15. Then multiply 7 to 13 and you will get 91. So we have 15 over 91. The probability of taking 2 black pens in the jar is 15 over 91.
Example number 4. There are 6 black socks and 4 white socks in a drawer. If one sock is taken out without looking and then a second one sock is taken out, what is the probability that both of the socks will be black? We know that it is a probability of dependent events because there is no replacement. To answer this, we need to, first is to get the probability of getting first black sock, which is equal to 6 over 10 or 3 over 5 if simplified. Next, the probability of getting second black sock, which is equal to 5 over 9. After that, the probability of getting 2 black socks, which is equal to 3 over 5 times 5 over 9 equals to 15 over 45. We can see that it still can be simplified by their GCF of 15. So if simplified, we are going to get 1 over 3 or 1/3. The probability of picking 2 black socks is 1 over 3 or 1/3.
And for the last example, we have example number 5. At the tire store, 5 out of 50 tires are defective. If you purchase 4 tires for your vehicle and they are randomly selected from a set of 50 newly shipped tires, what is the probability that all 4 tires will be defective? Once chosen, the tires are not replaced. Since there is a statement about no replacement, as we know it is a probability of dependent events.
So, we are going to use the formula to solve it. Step 1. Find the probability of each event. First, the probability of defective tire number 1, which is equal to 5 over 50 or 1 over 10 if simplified. Second, the probability of defective tire number 2 is 4 over 49. Third, the probability of defective tire number 3 is 3 over 48, or 1 over 16 if simplified. Lastly, the probability of defective tire number 4 is 2 over 47. Notice how we always subtract 1 as the list go on? It's because after each tire, 1 tire is excluded. Since we already got the probability of all dependent events, all we have to do is multiply all the probability that we got. 1 over 10 times 4 over 49 times 1 over 16 times 2 over 47, which is equal to 8 over 368,480. We can simplify this by their GCF, which is 8. So now we can have 1 over 46,060 as our final answer. So, the probability of choosing 4 defective tires out of a set of 50 tires is 1 over 46,060.
And that's all for today. Thank you for listening, and I hope you learned something.
Hi guys! Hi classmate! Mababa din ba ang grades mo sa math last quarter and gusto mong bumawi ngayong quarter? Sa tingin ko makakatulong itong link na to para sa susunod na exam.
Mababa ba ang nakuha mong grade last quarter and you're planning to elevate it? Do you want to perfect your next exam in math? If your topic is about solving problems involving permutation, then you're in the right place. Because here, when you click it, you perfect it.
Hi everyone, my name is Angel and you are here to learn how to solve different problems involving permutation. But first, what is permutation? Well, permutation refers to the different possible arrangement of a set of objects.
Permutation is also the order of the arrangement of object is important. For example, 1, 2, 3, 4 is not the same as 2, 3, 4, 1.
In this topic, we will solve different problems involving permutation of objects taken all at a time.
Involving permutation taken all at a time.
Circular permutation
and distinguishable permutation.
Hi, I'm Yancy. First, let's start with permutation of objects taken all at a time. Permutation taken all at a time means all of the object in the arrangement, meaning lahat ng object ay kasama or kasali sa arrangement. This can be used straight in the form of permutation quantity n, n. To solve, we will use n factorial wherein n is the number of objects. For example, in how many ways can 7 CDs be played on a DVD player? Now let's use the permutation quantity n, comma n equal to n factorial. Let's substitute the n as 7 dahil ito ang bilang ng CDs na ipi-play. Next step is solving the 7 fractional. To solve it, we have to multiply the 7 in every number that is less than 7. 7 times, 6 times, 5 times, 4 times, 3 times, 2, and times 1. And the answer is 5040. There you have it. The answer is 5040 ways of arrangement can the 7 different CDs can be played in a DVD player.
Easy, right? If you still don't get it, here's another example.
Amaya is planting flowers. Her flowers are rose, tulip, sunflower, daffodil, and daisy. The available flower pots are 5. In how many ways different arrangements can Amaya plant all of her flowers on the pots? Now let's write the given 5 flowers and 5 pots. Let's solve using the form of permutation quantity n, comma n is equal to n factorial. Substitute the n as 5 because we have 5 flowers, same as the pots. Lastly, let's solve for the 5 factorial multiplying by 5 in each number below 5. 5 times, 4 times, 3 times, 2, and times 1 is equal to 120. There are 120 different arrangements of 5 flowers in 5 pots.
Paano naman pag hindi lahat kasama sa arrangement? Paano natin isosolve?
Well, don't you worry because Shane will explain it to you.
Permutation of n objects taken r at a time. Dito, hindi lahat ng objects ay kabilang sa bawat arrangement. So, paano mo malalaman kung ilang arrangements kung hindi naman lahat ng objects ay kabilang? You can use the form p quantity n, r and the formula n factorial over the quantity n minus r factorial, wherein n is the number of objects and r is the number of objects taken. Now we're ready to solve problems involving permutation taken r at a time. I'll give you an example. In how many ways can Kurt arrange his shoes if he has a collection of 6 pairs of shoes and 8 available spaces in his shoe rack? First, illustrate the form with the formula. P quantity n, r is equals to n factorial over the quantity n minus r factorial. Second, substitute the n as the number of objects and r as the number of objects taken. Now, it's 8 factorial over the quantity 8 minus 6 factorial. Now, it's 8 factorial over the quantity 8 minus 6 factorial. Third, we have to solve for the parentheses in the denominator. 8 minus 6 is 2. Now, our denominator is 2 factorial and our numerator is 8 factorial. Fourth, we have to expand both numerator and denominator. After that, cancel the same number. Now, to get the final result, we have to multiply all the remaining numbers. It's 8 times 7 times 6 times 5 times 4 times 3. And the answer is 20,160 ways.
Sa tingin ko, kailangan mo ng second example. Here's another one.
Here's another example. There will be a 9 total of students competing for a math club quiz B. The competition will be held in a classroom with 15 available seats. In how many ways can the students be arranged or seated within the given seats? First, illustrate the form with the formula. P quantity n, r is equals to n factorial over the quantity n minus r factorial. Second, substitute the n and the r. Third, we have to solve for the parentheses in the denominator. 15 minus 9 is 6. Now, our denominator is 6 factorial and our numerator is still 15 factorial. Now, we have to expand both numerators and denominator. After that, we have to remove or cancel all the same numbers. And to get the final answer, we have to multiply all the remaining numbers. Now, the final answer is 1,816,214,400 ways.
Paano malalaman kung pabilog i-arrange? Parang trip to Jerusalem, ganon. Paano malalaman kung ilang ways?
Angel, ikaw nang bahala.
Let's talk about circular permutation. Circular permutation is the total number of ways in which n distinct objects can be arranged around a fixed circle and there is no starting and ending point. Sa Tagalog, ang circular permutation ay ang arrangement ng mga bagay sa isang bilog na kung saan walang unahan at walang hulihan. Let's use the permutation is equals to n factorial over n to solve this problem. This can demonstrate in a form of permutation is equals to n factorial over n, or it can also illustrate in a form of permutation is equals to quantity n minus 1 factorial. I'll give you an example. How many ways can 7 people be arranged in 7 capsules of a Ferris wheel? Let's use the permutation is equals to n factorial over n to solve the problem. Substitute the n as 7, then expand the 7 factorial and cancel the same number from the denominator. And lastly, multiply all the remaining numbers and the answer will be 720 ways. Let's try to solve the same problem but in different form. This time we will use the permutation is equals to quantity n minus 1 factorial. Substitute the n and minus it to 1. Then solve 6 factorial by multiplying 6 to all the numbers less than 6, and then your answer will be the same, 720 ways. Now, let's try to solve a different problem. This time, the problem we will solve is, how many ways can 8 different bells be arranged in a cat collar? Let's use the permutation is equals to n factorial over n to solve this problem. Just like what we did on the previous problem, first, let's substitute the n as 8, and then expand 8 factorial and then cancel the same number from the denominator. And lastly, multiply all the remaining numbers and your answer will be 5,040 ways. Now, let's try to solve the same problem, but this time the form we're gonna use is the permutation is equals to quantity n minus 1 factorial. Firstly, we need to substitute the n and minus it to 1. Then solve 7 factorial by multiplying 7 to all the numbers less than 7. And the final answer is still the same, which is 5,040 ways.
We are down at the last topic. Then, it's your turn.
And now we're here in the last topic. Our last topic is all about distinguishable permutation. In this permutation we're in, some objects are duplicate or similar. Meaning in Tagalog, sa permutation na ito ay ilang mga object ay magkapareho. The numbers of distinguishable permutation of an object where A are alike, B are alike, and along with others. You can illustrate it by permutation is equal to n factorial over a factorial, b factorial, and so on. You didn't get it? Let's have an example. How many distinguishable permutation for the word Mississippi taken all together? In the word Mississippi, we have 11 letters. Therefore, our n factorial will be 11 factorial. And there are letters that are repeated. Those letters are I repeated 4 times, S repeated 4 times, and P repeated 2 times. And now, let's substitute all the given values. Permutation is equal to 11 factorial over 4 factorial for the I, 4 factorial for the S, and 2 factorial for the P. Now, let's solve all the factorials. Permutation is equal to 11 factorial, which is 11 factorial is equivalent to 39,916,800. And then, the factorial from the denominator. 4 factorial is equal to 24, and another 4 factorial is equal to 24, and 2 factorial is still 2. And our next step is multiplying all the denominator. 24 times 24 times 2 is equal to 1,152. And now we know that our numerator is equal to 39,916,800 and our denominator is equal to 1,152. We need to divide the numerator and the denominator to get the answer. 39,916,800 divided by 1,152. And the final answer is 34,650 distinguishable permutation in the word Mississippi. Another example, Chloe has a collection of 7 markers, with 4 of them being the same color, which is blue, and another 3 markers are all different color. And how many distinguishable permutation will there be? Chloe has a collection of 7 markers. That's our N. And she have 4 markers that are the same color, which is blue. Let's substitute this to our formula. Permutation is equal to 7 factorial over 4 factorial. Let's expand the factorials and cancel the same number. 7 times 6 times 5, cancel 4 and another 4 from the denominator. And now, let's multiply all the remaining number. 7 times 6 times 5, and the final answer is 210 distinguishable permutation.
Now I bet you can perfect your exam in permutation, whether it's
Permutation taken all at a time,
involving permutation taken R at a time,
circular permutation,
and distinguishable permutation.
Get kick.
What is combination? In the definition, combination is the number of ways of selecting from a set when the order is not important. In combination, ABC, BCA, CAB, ACB, BAC, CBA are just the same. Hence, that is just one combination. The keyword in combination is the word of selecting. I want you to remember combination of object taken all of a time, which means n equal to r is always equal to 1. Meaning, combination 5, 5, combination 10, 10, combination 37, 37, combination 1000, 1000 are all equal to 1.
Ang lesson natin sa math ngayon is all about solving problems involving combination. For our example number 1, in how many ways can a committee consisting of 4 members be formed from 8 people? So yung pinag-uusapan dito is yung committee. So yung formula natin sa problem nito ay C n, r is equal to n factorial over n minus r factorial times r factorial. So yung n natin dito is 8 and yung r natin is 4. So, isubstitute natin yung formula natin sa ating given. So, combination 8, 4 is equal to 8 factorial over 8 minus 4 factorial times 4 factorial is equal to, solve natin, 8 factorial, 8 minus 4 factorial is equal to 4 factorial times 4 factorial. So, i-expand natin sila. 8 factorial magiging 8 times 7 times 6 times 5 times 4 factorial. 4 factorial, expand natin yung isang 4 factorial magiging 4 times 3 times 2 times 1. Ngayon, i-cancel out natin sila. Si 4 factorial, cancel out with 4 factorial. And si 4, divisible siya sa 8, magiging 2 si 8. And si 3, divisible siya kay 6. Si 6, magiging 2. So, ika-cancel out natin si 2, cancel out din natin itong si 2. So, yung natira natin dito is yung 2, 7, and 5. So, yung denominator natin is 1. So, ngayon, multiply natin siya. 2 times 7 is equal to 14. 14 times 5 is equal to 70. So, in how many ways can a committee consisting of 4 members be formed from 8 people? The answer is 70 ways. So, for our example number 2, in how many ways can Tony choose 3 books from a list of 8 books? So, sa problem nito, madidetermine natin na isa siyang combination from the word choose. So, yung formula ulit natin dito sa problem nito ay ito. C n, r is equal to n factorial over n minus r factorial times 3 times r factorial. So, yung n natin is 8 and yung r natin is 3. So, simplify natin siya, substitute natin yung formula sa ating given. So, combination 8, 3 is equal to 8 factorial over 8 minus 3 factorial times 3 factorial. I-solve natin. 8 factorial over 8 minus 3 factorial is equal to 5 factorial times 3 factorial. So, expand natin yun itong given na ito. Si 8 factorial magiging 8 times 7 times 6 times 5 factorial. Sa denominator naman, over 5 factorial, copy natin. Si 3 factorial, expand natin siya, magiging 3 times 2 times 1. So, ngayon, mag-cancel out tayo. 5 factorial, cancel to 5 factorial. Si 3, cancel kay 6, magiging 2 si 6. Ngayon, si 2, cancel natin siya kay 2. So, yung natitira natin dito ngayon ay si 8 and 7. And yung denominator natin is 1. So, 8 times 7 is equal to 56 ways. So, in how many ways can Tony choose 3 books from a list of 8 books? The answer is 56 ways. For example number 3, in how many ways can 2 chemists and 3 physicists be chosen to make a team if there are 7 chemists and 9 physicists who are qualified? So, sa problem na ito, dalawa yung involved. The chemists and the physicists. So, para makagawa daw tayo ng team, ang kailangan natin sa chemist ay 2, and sa physicist naman ay 3. Pero sa chemist, 7 yung qualified, sa physicist naman, 9 yung qualified. So, ilan nga ba yung mga pipili natin sa kanila? So, for our formula sa problem na ito ay combination n, r is equal to n factorial over n minus r factorial times r factorial. Out of 7 chemists, ang pipili natin ay 2, and out of 9 physicists, ang pipili natin ay 3. So, sa chemist, ang n natin dito ay yung 7, and yung r natin is 2. Sa physicist naman, yung n natin dito ay 9, and yung r natin dito ay 3. So, 7 combination 2, 9 combination 3. Multiply natin, and simplify natin yung formula sa kanila. So, para sa 7 combination 2, simplify natin, si n factorial is equal to 7, and for our n minus r is 7 and 2. So, 7 minus 2 is equal to 5 factorial times 2 factorial. So, ganun na rin sa PCCs, simplify natin, 9 combination 3, n is equal to 9 factorial over 9 minus 3 is equal to 6
6 factorial times 3 factorial. So, simplify natin sila. Si 7 factorial magiging 7 times 6 times 5 factorial over, copy natin to, 5 factorial times 2. And ganun na rin gagawin natin sa kanila. Si 9 factorial magiging 9 times 8 times 7 times 6 factorial. And for our denominator, 6 factorial times 3 times 2 times 1. So, cancel out tayo. Si 5 factorial, cancel out kay 5 factorial. Si 2, cancel out kay 6. Si 6 magiging 3. So, yung natira na lang dito ay 7. Sa kabila naman, cancel out 6 factorial to 6 factorial. Si 2 kay 8 magiging 4. And si 3 kay 9 magiging 3. So, yung natira na lang is si 7 and 3. And dito naman sa kabila ay si 3, 4, 7. So, multiply natin sila. 7 times 3 is equal to 21. And 3 times 4 is equal to 12. And 12 times 7 is equal to 84. So, 21 times 84 is equal to 1,764. So, in how many ways can 2 chemists and 3 PCCs be chosen to make a team if there are 7 chemists and 9 PCCs who are qualified? So, in how many ways nga po ba? So, the answer is 1,764 ways.
This is Great and Jade. We present you the difference between permutation and combination. Did you know that a permutation and combination are not the only things we encounter in our competitive tests or in school? In fact, we are confronted with this in our daily lives or activities to solve real-life difficulties. Now, what exactly is a permutation? A permutation is a mathematical technique that determines the number of possible set arrangement. When the order of the arrangement is important, the order matters. So, what exactly is a combination? A combination is a mathematical technique that determines the number of possible arrangement in a collection of items where the order of the selection does not mathematically matter. The order doesn't matter. And about a formula, the number of permutation of n things chosen at the time is found using permutation of n comma r is equal to n factorial over quantity n minus r quantity factorial. And about the number of combination of n things chosen at the time is found using combination of n comma r is equal to n factorial over quantity n minus r quantity factorial times r factorial. And we also have a keyword to identify a combination or permutation question. The keyword that permutation are arrangement, ordered ways, unique, permutation. And about the keyword of combination are select, choose, pick, and combination. So let's go with the worded problems.
Problem number 1. Arrangements of 8 people at a round table.
In this problem situation, we have a keyword arrangement and the order does matter. Therefore, this is a permutation problem. We can solve it using circular permutation formula, permutation of quantity n minus 1 quantity factorial. Because of the word round, our n is equal to 8. So by applying substitution, we have permutation of quantity 8 minus 1 quantity factorial. 8 minus 1 is 7, so we have 7 factorial. By expanding it, we have 7 times 6 times 5 times 4 times 3 times 2 times 1. And it is equal to 5,040. Therefore, there are 5,040 ways we can arrange 8 people in a round table.
5 basketball players needs to select a captain and a co-captain.
By the keyword select, we can identify that it is a combination. This can be solved by using the combination formula. combination of n comma r is equal to n factorial over quantity n minus r quantity factorial times r factorial. We can say that our n is equal to 5 since we have a total of 5 players in a basketball, and r is equal to 2 since we are selecting captain and co-captain of the team. Now we can substitute the given values to the formula. So we have the combination of 5, 2 is equal to 5 factorials all over quantity 5 minus 2 quantity factorials times 2 factorial. We can now evaluate our equation by computing first the operation inside the parentheses. 5 minus 2 is equal to 3. So we have 5 factorials times 2 factorial. Expand both the numerator and denominator. So we have 5 times 4 times 3 times 2 times 1 for 5 factorials over 3 times 2 times 1 for 3 factorials and 2 times 1 for 2 factorials. We can now cancel 3 both in the numerator and denominator and cancel 2 from the numerator and another to the denominator. Multiply the remaining factors. 5 times 4 times 1 is equal to 20 and 1 times 2 times 1 is equal to 2. For the last step, 20 over 2 is equal to 10. Thus, we have 10 different ways to select a captain and co-captain in a basketball team.
Question number 3. Joshua likes to invite 10 friends to go on a trip, but has a room for 6 of them. In how many ways can they be chosen?
Because we need to pick a subset from the whole set, this indicates that the problem is combination. First, write the formula that we are going to use, which is combination of n comma r equal n factorial over quantity of n minus r quantity factorial times r factorial. Then, let's identify the values of n and r in this problem. N is 10 and r is 6. Since there are 10 total participants in the given and there are only 6 rooms, combination 10, 6 equal 10 factorial over quantity of 10 minus 6 quantity factorial times 6 factorial. So first, we need to perform the indicated operation, which is subtraction, which will lead us to combination 10, 6 equal 10 factorial over 4 factorial times 6 factorial. After that, we will cancel the values of 6 factorial in the numerator and denominator. So, we will have 10 times 9 times 8 times 7 and 4 times 3 times 2 times 1. And then, we will multiply 10 times 9 times 8 times 7 is equal to 5040. Then, 4 times 3 times 2 is equal to 24. Lastly, divide it. 5040 divided by 24 is equal to 210. So, we have 210 ways.
Problem number 4. In how many ways can you rank your 6 favorite movies from a list of 12?
This is an example of permutation, so let us use the formula for permutation. N that is equal to 12 and R that is equal to 6. Let us solve the 12 minus 6. So 12 minus 6 is equal to 6 factorial. Then let us copy the 12 factorial from the numerator. So now we have 12 factorial over 6 factorial. Now, let's multiply 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. Then, let's cancel the 6 factorial from both numerator and denominator. Then, let us solve the 12 times 11 times 10 times 9 times 8 times 7 that is equal to 665,280.
Problem number 5. Choosing 5 volleyball players from a group of 10.
So for problem number 5, first we need to do is to find if this is a permutation or combination problem. As we can see, there's a word choosing, so we can say that this is a combination problem. We all know that combination is about choosing, selecting, and the order is not matter. The formula of our combination is combination n, r equal n factorial over quantity n minus r quantity factorial r factorial. Now
let's find our n and r at a time. As we can see, our n is equal to 10 and our r is equal to 5. So we have combination 10, 5 equal 10 factorial over quantity 10 minus 5 quantity factorial 5 factorial. Let's compute the operation inside the parenthesis, which is quantity 10 minus 5 quantity factorial. So we have 5 factorial because 10 minus 5 equals to 5. Next, we need to do is expand the numerator, which is 10 factorial, then cancel the 5 factorial in both numerator and denominator. Then multiply the remaining factors, which is 10 times 9 times 8 times 7 times 6 equals to 30,240. Then divide it with 5 factorial, so the answer is 252.
Problem number 6. Arrangement of permutation. There are 15 students in a math club. In how many unique ways can the students be elected as president, vice president, secretary, and treasurer?
We can identify that it is a permutation question by the keyword unique. Since it is a permutation problem, we're gonna use the formula for permutation, which is P quantity n, r quantity is equals to n factorial over quantity n minus r quantity factorial. We're gonna substitute the n and r, which is 15 and 4. By substitution, we're gonna get P quantity 15, 4 quantity is equals to 15 factorial over quantity 15 minus 4 quantity factorial. So first, we're gonna solve the one in the parenthesis, which is 15 minus 4. Then, we're gonna copy 15 factorial over 11 factorial. After that, we're gonna expand 15 factorial, which is 15 times 14 times 13 times 12 times 11. After solving, we're gonna get 32,760.
Problem number 7. Find the number of arrangements for the first 7 letters of the alphabet taken 2 at a time.
Every problem has a solution, so here's the explanation. First, we need to analyze the problem to know if it is a permutation or a combination. Then, we can say that this is a permutation because of the keyword arrangement. After that, write the formula of permutation. Permutation n, r equal to n factorial over n minus r factorial. What is n and what is r? Rn is equal to 7 and r is equal to 2. So permutation 7, 2 equal to 7 factorial over 7 minus 2 factorial, then subtract 7 and 2. 7 minus 2 is equal to 5. So we have permutation 7, 2 equal to 7 factorial over 5 factorial. 7 factorial is 7 times 6, 6 times 5, 5 times 4, 4 times 3, and 3 times 2 over 5 times 4, 4 times 3, and 3 times 2 in the numerator and denominator. So we have 7 times 6. 7 times 6 is 42, so the answer is 42.
Problem number 8. Lana would like to invite her 6th friend to go in a trip, but has only room for 4 of them. In how many ways can they be chosen?
This example right here is a combination. So let's solve this by using formula combination of n, r is equal to n factorial over quantity n minus r quantity factorial times r factorial. In that n is equal to 6 and r is equal to 4, first let us minus the 6 minus 4, that is equal to 2, then copy the 6 factorial and also the 4 factorial. Then 6 times 5 times 4 over 2 factorial and then 4 factorial, then let us cancel the 4 factorial from denominator and numerator. 6 times 5 is equal to 30. 30 divided by 2 is equal to 15. Therefore, our 15 many ways.
Problem number 9. Choosing 10 questions to answer out of 15 questions in a test.
The keyword used is choosing, which makes it a combination. We can solve it by using the combination formula. combination of n, r is equal to n factorial over quantity n minus r quantity factorial times r factorial. By substitution, we have the combination of 15, 10 is equal to 15 factorial over quantity of 15 minus 10 factorials times 10 factorials. Evaluate the equation, then compute the operation inside the parentheses. So, we have 5 factorials. Now, we have 15 factorials over 5 factorials times 10 factorials. Expand both the numerator and denominator. Then, cancel 10 both in the numerator and denominator. Multiply the remaining factors. Then, divide the product on the remaining factors. So now, we have 360,360 over 120 is equal to 3,003 ways.
Problem 10. Suppose there are 35 applicants for 3 computer programmer positions in a company. In how many ways can the 35 applicants be selected as one of the programmer positions in the company?
This problem requires us to choose from a whole, so it is a combination. We can solve it using combination formula. Combination of n, r is equals to n factorial over quantity n minus r quantity factorial times r factorial. Then substitute the values, then perform the operation inside the parentheses. Quantity 35 minus 3 quantity factorial, so we have 32 factorial. Then expand the factorial of 35, then we use the cancellation method. So the values of 32 factorial in both numerator and denominator is cancelled out. And lastly, we multiply the remaining factors. 35 times 34 times 33, which is 39,270. Then divide it with 3 times 2 times 1, which is 6. So the answer is 6,545.
There are 6,545 ways on how to programmer position be selected from 35 applicants.
In how many ordered ways can 3 singers be seated in first, second, and third seats in the theater?
For our solution, permutation quantity of 3, 3 is equal to 3 factorial. Permutation quantity of 3, 3 is equal to 3 multiplied by 2 multiplied by 1 is equal to 6 ways. The keyword ordered ways help us identify that it is permutation. We will use the formula permutation quantity of n, n is equal to n factorial. By substitution, we have permutation of 3, 3 is equal to 3 factorial. Expand 3 factorial, it is used, equal to 6. That's why we have 6 ways.
Based on the definition and example provided, we can now conclude that a permutation is a sequential combination. The number of combinations is always less than the number of permutation. In permutation, the arrangement or order of object is important, where it is not in combination. This is Great and Jade.
Grade 10 Circon Math Video Lesson prepared by Kembao Andy S. Santos Iris Giselle J. Saldana Bernadette E. Sambile Nuela B. What lesson are we going to learn for today? The lesson we will study for today is solving problem involving probability of independent events. In this lesson, we were talking about independent and dependent events. Both of these use the conjunction "and" instead of "or." Thus, the operation that we're going to apply is multiplication. Independent event. If the outcome of one event has no effect on the outcome of a second event. However, if the outcome of one event has an effect on the outcome of a second event, then the two events called dependent event. The formula that we're going to use for independent event is probability of A and B equals probability of A times probability of B. And for the dependent event is probability of A and B equals probability of A times probability of B following A. Also, you have to remember that if there is replacement, then we have an example of independent event. However, without replacement is for independent event. For you to understand more about these two, let's have an example. Since our topic is solving problem involving independent event, so we will focus on independent event. Problem number 1. A box contains 6 violet balls, 5 black balls, and 7 green balls. Chloe draw a ball, then return it to the box. She draw a second ball. What is the probability of the first ball is green and the second one is violet?
In this example, we have a box contains 6 violet balls, 5 black balls, and 7 green balls. Chloe draws a ball and returns it to the box. She draws a second one. What is the probability that the first ball is green and the second one is violet? Can you tell me if this example is an example of independent or dependent event? Yes, you're right. It is an example of independent event. Now we can now use the formula of probability of A and B equals probability of A times probability of B. The probability of A or getting a green ball is 7 over 18 since we have 7 green balls out of 18 balls in a box. After picking the first ball, Chloe returned it to the box. Now to find the probability of B or getting a violet ball is 6 over 18 since we have 6 violet balls over 18 balls in a box. We can now solve 6 times 7 is 42 and 18 times 18 is 324. 42 over 324 can still be simplified by dividing both numerator and denominator by 6. So we have 7 over 54 since 42 divided by 6 is 7 and 324 divided by 6 is 54. Therefore, the probability that the first ball is green and the second one is violet is 7 over 54.
Problem number 2. In tossing a coin and rolling a die, find the probability that a coin show up tail and a die show up too.
In tossing a coin and rolling a die, find the probability that a coin shows up tail and a die shows up too. In this example, we have two experiments, tossing a coin and rolling a die. Since this example of independent event, we can use the formula probability of A and B is equal to probability of A times the probability of B. The probability of A is getting tail is 1/2 since we have one tail in a coin, over 2 since we have 2 possible results in tossing a coin. We have a head and a tail times the probability of B, or a die shows up 2 is 1/6, since we only have one face of 2 in a die. There are 6 possible results in rolling a die. We can now solve. 1 times 1 is equal to 1 and 2 times 6 is equal to 12. Therefore, the probability that a coin shows up a tail and a die shows up 2 is 1 over 12.
Problem number 3. A bag contains 8 red, 5 blue, and 2 orange marbles. If you pull 2 marbles one at a time with a replacement.
A bag contains 8 red, 5 blue, and 2 orange marbles. If you pull 2 marbles one at a time with replacement. Sa tingin nyo, ito ba ay independent events or dependent events? Yes, ito ay independent events dahil sa with replacement. Kaya ang gagamitin nating formula ay probability A and B equal probability A times probability B. Probability A, 8 over 15. 8 dahil meron tayong 8 red marbles. 15 dahil 8 plus 5 plus 2 is equal 15. Times probability B, 5 over 15. 5 dahil meron tayong 5 blue marbles. 15 dahil 8 plus 5 plus 2 is equal 15. Then, 8 times 5 is equal 40. 15 times 15 is equal 225. 40 over 225 ay pwede pa natin itong i-divide by 5. Kaya meron tayong 8 over 45. 8 dahil 40 divide 5 is equal 8. 45 naman dahil 225 divide 5 is equal 225. Kaya ang marbles natin ay 8 over 45.
Problem number 4. A card chosen at random from a deck of 52 cards. It then replaced and a second card is chosen. What is the probability the first card is Jack and the second one is 8?
A card is chosen at random from a deck of 52 cards. It is then replaced and the second card is chosen. What is the probability that the first card is Jack and the second one is 8? Can you determine if it is an example of independent or dependent event? Yes, it is an example of independent event with the keyword of replace. Now to solve this problem, we have to use the formula of probability of A and B equals probability of A times probability of B. The probability of A or getting a jack is 4 over 52 since we have 4 possible outcomes out of 52 cards. After the first card is chosen, it is then replaced. Now to find the probability of B or getting an 8 is 4 over 52 since we have 4 possible outcomes out of 52 cards. We can now solve. 4 times 4 is 16 and 52 times 52 is 2,704. 16 over 2,704 can still be simplified by dividing both numerator and denominator by 16. Now we have 1 over 169 since 16 divided by 16 is 1 and 2,704 divided by 16 is 169. Therefore, the probability that the first card is Jack and the second one is 8 is 1 over 169.
So let's proceed to our last example. A jar contains 6 orange marbles, 4 black marbles, and 8 blue marbles. Christine draw a marble, then return it to the bag. She draw a second marble. What is the probability that the first marble is blue and the second one is orange?
A jar contains 6 orange marbles, 4 black marbles, and 8 blue marbles. Christine draws a marble, then return it to the bag. She draws the second marble. What is the probability that the first marble is blue and the second one is orange. Sa tingin nyo, ito ba ay independent events or dependent events? Yes, ito ay independent events dahil sa keyword na return it to the bag. Kaya ang gagamitin nating formula ay probability A and B equal probability A times probability B. Probability A, 8 over 18. 8 dahil meron tayong 8 blue marbles. 18 dahil 6 plus 4 plus 8 is equal 18. Times probability B. 6 over 18. 6 dahil meron din tayong 6 orange marbles. 18 dahil 6 plus 4 plus 8 is equal 18. Then, 8 times 6 is equal 48. 18 times 18 is equal 324. 48 over 324 ay pwede pa natin itong i-divide by 6. Kaya meron tayong 12 over 81. 12 dahil 48 divided 6 is equal 12. Then 324 divided 6 is equal 81. Kaya ang probability ng first and second marble ay 12 over 81.
Occurrences of independent and dependent event. When the occurrence of one event does not affect the probability of the occurrence of the other event, this is independent event. When the occurrence of one event affects the probability of the occurrence of the other event, this is dependent event.
An example of dependent and independent events. First example, a vase consists of flower with different type. 4 rose, 3 iris, 5 daisy, and 5 lily. What's the probability getting? Meron tayong dalawang problem. Problem A and problem B. Problem A, daisy flower at the first try, and then a lily flower on the second try, with replacement. Problem B, roses flower at the first try, and then an iris flower on the second try without replacement. Problem A is example of independent events. Dahil sa word na replacement, mababalik or pwede pa tong ibalik. Problem B is example of dependent events. Dahil sa word na without replacement. Dahil hindi na ito pwedeng ibalik o hindi na mababalik. Another example, a bag contains 3 red, 5 blue, and 2 orange marbles. If you pull 2 marbles on at one time with replacement. Example ito ng independent event dahil sa word na replacement. A jar contains 5 green, 10 red, and 7 blue marbles. 2 marbles are pulled one at a time without replacement. Example naman ito ng dependent event dahil sa word na without replacement. Another example, a plate contains 3 banana, 6 longan, 2 rambutan, and 5 grapes. Kevin randomly chose a fruit, eats it, and then randomly chose another fruit. What is the probability that Kevin chose a rambutan and then a banana? Example naman ito ng dependent events. Dahil sa word na it's it, kinain na niya, kaya hindi na ito pwedeng ibalik. Last example, Jazz has 3 blue chair, 5 black, 4 pink. Jazz randomly select a chair to sit, and then they put it back and choose another chair. Find the probability of selecting a blue chair and a pink chair. Example naman ito ng independent events. Dahil sa word na put it back.
Here are the formulas for solving independent and dependent events. Independent events. If two events A and B are independent, then the probability of both events occurring is the product of the probability of A and the probability of B. In symbol, probability of A and B is equal to probability of A multiplied to probability of B. And remember that and means multiplication. Let's proceed to dependent events. If two events A and B are dependent, then the probability of both events occurring is the product of the probability of A and probability of B after A occurs. In symbol, probability of A and B is equal to probability of A multiplied to probability of B following A.
Hey everyone, I am Dixie Medina and I'm going to show you how to solve the independent and dependent event. Example. If you roll a 6-sided die and flip a coin, what is the probability of rolling a 5 getting heads? The first thing we should do is to write down the formula. But in order to use this formula, we need to know the probabilities of each event. For that, you should know that the probability of an event is equal to the total number of favorable outcomes divided by the total of possible outcomes. For the first event, there is only one favorable outcome, which is a rolling 5. A total of 6 possible outcomes since we're rolling a 6-sided dice. The result, the probability of rolling a 5 is equal to 1 over 6. On event, we know that the probability of getting heads is equal to 1 over 2 or 50%. And we know this because there's only one desired outcome, which is getting heads. And there are total of 2 possible outcomes since the coin can be landed as a head or tails. And now we have the probabilities of each event. We can now use this formula. And we have to do is multiply them together. 1 over 6 multiplied by 1 over 2 is equal to 1 over 12. As a result, the probability of rolling a 5 and getting heads is equal to 1 over 12 or 0.0833. Do an example for a dependent event. Suppose we have a box contains 10 marbles, 7 marbles are green and 3 marbles are blue. Based on this, we know that the probability of one green marble is 7 over 10 or 0.7. And the probability of one blue marble is 3 over 10 or 0.3. If we randomly select 2 marbles from this box, what is the probability of drawing green marble and then a blue marble without replacement? A common mistake in solving this problem is by using the formula and then multiply the probability each marble together. So we will have 7 over 10 multiplied by 3 over 10. However, this process is incorrect. This formula only be used in independent event, and we know that this is not an independent event, with the keyword of without replacement. As a result, this is a dependent event, where the probability of one event affects the probability of another event. For the first event, there are 10 marbles on the box, and since we have a total of 7 green marbles, the probability of throwing one green marble is 7 over 10 or 0.7. On event, the probability of drawing a blue marble is not 3 over 10. Since there is a total of 9 marbles left in the box, with a total of 3 marbles remaining, the probability of drawing a marble is now equal to 3 over 9, or 0.33. As you can see, the probability of drawing a blue marble has changed. First, it had a value of 0.3. As a result, this is a dependent event because the occurrence of the first event affected the probability of the second event. Now, to finish this problem, all we have to do is multiply their values together. 7 over 10 multiplied by 3 over 9 give us an answer of 7 over 30 or 0.233. Now, let's have an example using the same scenario. What is the probability of drawing 2 green marbles without replacement? To solve this question, we will use this formula except we have to make some modifications to it. The probability of A and B is equal to the probability of A multiply the probability of B after event A has occurred. We'll assign event A as drawing the first green marble. We'll assign event B as drawing the second green marble. The probability for drawing the first green marble is equal to 7 over 10. Therefore, the probability of drawing the second green marbles is equal to 6 over 9. 7 over 10 multiplied by 6 over 9 is equivalent to 7 over 15, or 0.4667.
Example number 1. A card is chosen at random from a standard deck of 52 playing cards without replacing it. A second card is chosen. What is the probability that the first card chosen is a queen and the second card chosen is a jack? So this is a dependent event because of the word without replacing it. So our symbol is E. Probability of A and B is equal to probability of A times probability of B following A. So, probability of A and B is equal to 4 over 52 times 4 over 51. Bakit 4 ang ating N? Kasi meron tayong 4 na queen sa isang standard deck of 52 playing cards. So, ang next event is mapabawas na siyang isa kasi kumuha na tayo ng isang queen. So, magiging 51 na lang siya. At may 4 din na jack sa isang standard deck of 52 playing cards. So, 4 over 52 times 4 over 51 is equal to 16 over 2,652. So, pwede natin siyang i-simplify. So, it equals to 4 over 663. Example number 2. 3 cards are chosen at random from a deck of 52 cards without replacement. What is the probability of choosing 3 aces? So, this is a definitely dependent event because of the word without replacement. So, ang symbol natin ay probability of A and B is equal to probability of A times probability of B following A. So, probability of A and B is equal to 4 over 52 times 3 over 51 times 2 over 50. Kasi, pumipili tayo ng isang aces na hindi natin siya binabalik. So, 4 over 52 times 3 over 51 times 2 over 50 is equal to 24 over 132,600. So, pwede pa din natin siyang simplify. So, is equal to 1 over 5,525. Example number 3. A dresser drawer contains 1 pair of socks with each of the following colors: blue, brown, red, white, and black. Each pair is folded together in a matching set. You reach into the sock drawer and choose a pair of socks without clothing. You replace this pair and then choose another pair of socks. What is the probability that you will choose the red pair of socks both times? So that this is a definitely independent event because of the word you replace this pair and then choose another pair of socks. So our symbol is probability of A and B is equal to probability of A times probability of E. So probability of A and B is equal to 1 over 5 times 1 over 5. Why they are both over 5? Because you replace this pair and then choose another pair. So, binalik mo siya. So, kaya rest lang yung kanyang N and R. So, 1 over 5 times 1 over 5 is equal to 1 over 25. That's the answer. So, example number 4. A card is chosen at random from a deck of 52 cards. It is then replaced and a second card is chosen. What is the probability of choosing jack and then an 8? So, this is an example of
independent events because of the word is then replaced and the second card is chosen. So, binalik mo yung kinuha mo. So, hindi na tatamaan or hindi nagkakaroon ng effect sa second event. So, our symbol is P. Probability of A and B is equal to probability of A times probability of B. Probability of A and B is equal to 4 over 52 times 4 over 52. Kasi meron 4 na jacks sa standard deck of 52 cards and may 4 din na 8 sa standard deck of 52 cards. Binabalik mo yung mga kinukuha mo kaya hindi na-apektuhan yung second event. So 4 over 52 times 4 over 52 is equal to 16 over 2704.